These aren't the A-list AI models you see in headlines. One reads your mind and turns your brainwaves into images. Another is a real-time video generator where you can drag your mouse to control movement as it's happening. This one builds infinite 3D worlds with consistent geometry, objects and shadows, a living simulation. Then there's a world learner multimodal model designed to understand how things work, creating educational images, teaching videos, and even illustrated books by reasoning through a full sequence of actions. And finally, an ultra-high resolution diffusion model that pushes image detail far beyond what most AI can render. Welcome to the weird side of AI. You're watching What's Next AI. The first one is absolutely wild. It's called Brain IT, and yes, it does exactly what it sounds like. It reads your brain activity and turns your thoughts into images. Here's what's happening. On the left, you see the original image a person is looking at. Brain IT scans their brain activity, specifically the fMRI signals, and reconstructs what the person is seeing without ever being shown the original. The result? An eerily similar image generated purely from their brain waves. Take this example, someone looking at a giraffe. The reconstruction doesn't just show an animal, it recognizes the shape, neck length, posture, even the direction it's facing. It's like the model can literally peek into what your brain is picturing. Now look at this snowboarder. The AI picks up the tilt, movement, and pose almost perfectly. It even senses the momentum of the scene. The textures, snow shadows, and motion lines are off, sure, but the overall structure, unbelievably accurate for something drawn from brain signals. It even handles complex compositions, like multiple people in one frame, and still manages to replicate the general layout and body poses. It's not flawless, but it's definitely creepy how close it gets. So how does it work? Brain IT uses a transformer-based architecture that analyzes brain signals from fMRI scans. It extracts two key layers of information: high-level semantics, what the image is about; low-level structure, where things are positioned and how they're shaped. Then it merges those two branches through a diffusion model that actually paints the reconstructed image. Think of it as combining what you're thinking with how your brain sees it. And compared to older mind-decoding models, Brain IT simply performs better. The objects are in the right orientation, the scenes are more coherent, and the benchmark scores clearly show it leading across most tests. For now, the team's released only the technical paper, no public code yet. But they've confirmed it's coming soon. When that drops, you can expect a flood of experiments trying to visualize thoughts directly. Brain IT proves that AI mind reading isn't just science fiction anymore, it's already happening. Next up, this one is seriously impressive. It's called Motion Stream, and it can generate videos in real time. What makes it even cooler is that you can literally drag your mouse around the canvas to control how objects move in the video. Let's take a look at how it works. In this first example, you start by generating a video live on the canvas. When you move your mouse on the left side, you can see the wave following your motion path instantly, with almost no delay. The tool claims to render at around 29 frames per second with roughly 0.44 seconds of latency, which is basically real time. And all of this runs on a single NVIDIA H100 GPU. Here's another example that shows how you can control movement in a much more detailed way. You can place a grid on the video and set it to static, meaning that part of the frame stays still. Then, if you place another grid and drag it, only that part moves. In this example, they add one grid over the dog's body and another over the background. The green grid moves the dog, while the red grid remains fixed. You can also go even more precise. By placing grids on the dog's nose and right arm, those parts stay completely still. Then, when you drag another grid over the left arm, only the left arm moves. It's almost like puppet animation, but generated through a real-time diffusion model. And it's not just rigid movement. The system also handles physics in surprisingly realistic ways. In one demo, when they drag a Shiba around, its whole body moves naturally with the right sense of weight and motion. The AI seems to understand basic anatomy and keeps the animation smooth. There's another fun test with a cup of tea. When you drag the cup, the liquid moves along correctly, spilling on the plate and table as you'd expect. The only glitch? The tea never stops pouring. It's like an infinite stream of tea, which is hilarious but technically still impressive. Here's how the system is built. Motion Stream uses two models, a teacher model and a student model. The teacher model creates high-quality but slower video generations. Those outputs are then used to train the student model, which can replicate similar quality in real time. That's how it achieves such low latency while keeping the visuals stable. Under the hood, it's built on top of Alibaba's WAN 2.1 open-source video generation framework, one of the most advanced systems available right now. So Motion Stream isn't an entirely new video model, but a smart real-time control layer built over it. Currently, there's a GitHub repo listed, but the code is still under internal review and might not be released publicly depending on the company's decision. Since this project is connected to Adobe, it's probably best not to expect full open-source access anytime soon. Still, the concept is amazing. Being able to interact with a video in real time and literally draw motion with your mouse could completely change how animation and video editing work in the future. Moving on, this AI is called World Grow, and it's honestly one of the most fascinating ones in the lineup. It can generate infinite 3D worlds that look realistic and maintain consistent geometry across every scene. In most traditional 3D world models, the system relies on Gaussian splatting, which basically means creating a world out of thousands of little dots floating in 3D space. It works, but it often leaves gaps or broken areas, so the results can feel incomplete or inconsistent. World Grow takes a completely different approach. Instead of just splatting points in space, it builds scenes using 3D blocks, kind of like digital Lego. Each scene is constructed piece by piece, which gives it far more structural and geometric coherence. Here are some examples. The system can create full indoor scenes, like furnished rooms with walls, lighting, and decor, as well as outdoor environments with natural layouts and believable terrain. You can immediately see how this could be a game changer for interior design, architecture, or even open-world game generation. Now, here's a quick look at how it works under the hood. First, the model starts by collecting and preparing these 3D scene blocks, things like room layouts, outdoor segments, and furniture setups. Those are then converted into structured 3D data that the model understands. Next comes the 3D block in-painting stage. This step fills in any missing details to make sure everything lines up. The walls, the floor, the lighting, everything connects properly. After that, the system runs a fine structure refinement stage, which adds realistic materials, lighting, and surface textures to bring the whole scene to life. The results look far more detailed and polished than typical generated 3D spaces. Because it's built from these modular 3D blocks, the world stays consistent even as it expands. You can keep looping the generation process to extend the environment further and further, but everything you built before remains perfectly aligned. If you scroll to the top of their project page, you'll see they've listed a GitHub repo that's currently being prepared for public release. It says pre-trained weights, and full training and inference pipelines are planned, which means the team does intend to make it available soon. World Grow shows how AI-generated 3D environments are moving from chaotic point clouds to structured, scalable worlds, and it's setting the stage for the next wave of truly infinite 3D creation. Now, this one's really interesting. It's called EMU 3.5, and it's an open-source multimodal model. That means it doesn't just understand language like GPT, it can also analyze, generate, and edit images all within the same system. For example, if you ask it how to sculpt a Mars Explorer figure, it doesn't just give you text instructions. It actually creates a step-by-step visual guide, generating an explainer image for each step along the way. Because it's multimodal, it can reason through both text and images at the same time. You can also ask it something like how to cook a dish, and it'll produce a full sequence of related images, all consistent in lighting, style, and setting, as if they're frames from the same video. It's remarkably coherent. And because it can process images as inputs too, you can upload something like an unfinished figure design and tell EMU 3.5 to continue painting or sculpting it, eventually rendering it as a completed figurine. The result actually looks like a finished product. What makes this model even more powerful is how easily it can create educational or illustrated content. On the official demo page, they show how it can generate both narrative text and matching images, which makes it perfect for producing teaching materials. The model also supports image editing features like clothing changes and multi-image composition. EMU 3.5 has strong reasoning and world understanding too. It can handle visual puzzles, adjust camera perspectives, generate professional portrait angles, or remove handwriting and watermarks from documents with precise control. Looking at the benchmarks, EMU 3.5 consistently outperforms other leading image models, including Qwen Image Edit, GPT's image module, and Nano Banana, across both image generation and editing tests. The best part is that the models are already available. Their GitHub page includes setup instructions for downloading and running it locally. Overall, EMU 3.5 feels like a true world learner, a single model capable of reading, reasoning, illustrating, and teaching. And it could redefine how we create visual educational content with AI. Finally, this AI is seriously powerful. It's called DyPE, and it's an open source model that can generate ultra-high resolution images natively, something most diffusion models still struggle with. Take a look at these examples. When you zoom in, the detail is incredible. Every texture, every pixel, all super sharp. You can clearly see the details on the person's face, the blades of grass, even the fingers. It's generating true 4K level imagery without relying on any post-upscaling tricks. Here's another example. As you zoom in on the scene, even the distant buildings stay crisp and defined. The textures hold up perfectly, and nothing breaks apart into noise or blur. The same goes for this image. Look closely at the armor. Every surface reflection, every small groove remains razor sharp. To show how much of an improvement this is, the researchers compared DyPE with another open source model called Flux. If you ask Flux to produce a 4K image, you'll get something that looks good at first glance. But when you zoom in, the fine details are soft or missing. When you apply DyPE, though, the difference is huge. The image becomes significantly sharper and more accurate. Here's a side-by-side. On the left, the Flux version looks slightly washed out and rough around the edges. On the right, DyPE captures textures, lighting, and object edges far more precisely. Even at very high resolutions where most models start to break down, DyPE stays stable and consistent. The reason it works so well is that DyPE was designed specifically for high-resolution generation rather than just scaling up smaller images. It directly optimizes the diffusion process to preserve detail and structure during generation. And the best part? The developers have already released the full code. You can head over to their GitHub repo and find everything, from installation instructions to pre-trained weights, so you can test it yourself locally. DyPE is pushing the limits of what open-source image models can do. At this rate, we might not even need to upscale images or videos in the future. They'll already be born in perfect 4K quality straight from the model. So that's 5 of the strangest and most fascinating AI models out right now, each doing something the big names haven't even touched yet. These tools might look experimental today, but they're showing us where AI creation is heading. Real-time control, reasoning, and detail that doesn't need post-processing. It's weird, it's ambitious, and it's exactly why I love exploring this side of AI. If you're interested in reading further or trying out any of these models yourself, all the links are in the description below. Don't forget to hit like, subscribe, and turn on notifications. It really helps the channel and lets me keep bringing you more of these hidden AI gems. This is What's Next AI. See you in the next one.